No, you're fine.
There'll only be a couple sparks.
Mm-hmm.
I didn't realize it was happening because I would light it and then run, because but I finally lit it and then ran like backwards to see what happened, and I noticed all the sparks flying behind me. Not a good idea.
Pretty good.
We're gonna put the pennies in the bottom and see if it melts them.
I'm gonna see what happens here
Burn
first.
it.
Get close.
Yay.
There you go. Oh, no, that was a magnesium.
There's a magnesium.
Oh, so close.
I know, that's what I was thinking too. More magnesium.
It's trying.
It wants to go. So sometimes the tough part here is getting it started. And I'm not going to give up. For a while.
Here, we'll do like a pan shot. This, Zach, the dress up there.
Just pour the whole bottle in.
Not the amount. It's where it
Here, I gotta get you too.
matters.
Here, I'll get me.
I am going to try a double up here. Triple up, actually.
Oh, we're tripling up now.
Well,
Big guns.
Those are actually the exact sparklers I used.
Are they?
now don't try this at home.
John already has. Too late.
What? Don't try this out again. John already does this on the weekends.
Yeah.
I
He
do.
creates his own thermite.
It was fun.
Contraband thermite lab.
It's not contraband.
This is a car. Oh, that was John. It's John. It was all caused by John. This is a car. This is the car.
Magnesium.
And because we'll be in France, I catch that.
Whoa!
Whoops.
And that should be molten iron.
That hurt my arm.
I
And
thought
you guys can come
burned your
closer now.
hand off. Oh, cool.
No, hot.
Oh, this looks like a job. Burning pencil. Oh, there's the ashes. Oh my gosh.
So that's
like-
about
look at the flame, it's
825
like
kilojoules per mole when
It's
you don't
burning
have the
the
water
penny?
around.
It's green.
I did not think you could burn pennies.
You can cut them.
Yeah, that's
Melt
zinc
them.
oxide. Pennies are
A lot of zinc now.
Yeah,
Mostly
Natalie, didn't you
zinc.
do an experiment or something where you
So I
tested
wouldn't be breathing too much
fire
of the
color
white dust.
versus
Yeah.
I don't think so.
Natalie.
Natalie.
Natalie, come over here, hon.
You're gonna
Move
get
the other
Natalie,
way.
this Natalie.
No,
No, the
move
dust.
this way.
Come over here, hon.
I'm just saying I wouldn't breathe too much of the
I'll be
white. It's just
passing out in
zinc
government
oxide.
class. I used to do it.
Kill you.
Go that way.
So a little bit more spectacular.
Souvenir?
Sorry?
Souvenir?
When it cools,
That might take a while.
Yeah, I know, that might take a while.
you can, and you'll have the. And notice, by the way, the wood in the pencil burns dramatically, but the graphite is kind of like the sword and the stone. Whoever pulls the graphite from the stone will be the next, student who earns a 5 on the AP Chem exam. To Excalibur. Dun, dun, dun.
Can we try it while it's still molten?
But the wood kind of bursts into flame pretty. Actually,
Pretty
the reason
quickly.
I do this, save those pencils, and you can use it. We'll use them for electrode when we do electrochemistry. I'm a big. The yellow is probably the residue from the pencil and the lead paint and all that. But that's now just the aluminum. Most of that white smoke you saw was aluminum oxide, which is a very talcumy powder. But the iron and the iron, that's a big chunk of what was now molten iron. So you can calculate let's say half of 825 kilojoules, let's say about 400 kilojoules of energy went into heating up roughly 100 grams of iron, it's 110 grams of iron. Well, 400 kilojoules in the specific heat capacity of iron is about half a joule per gram degree Celsius. So back of the envelope, if you just think about it, the iron should actually get to a temperature of about 2,500 degrees Celsius, which is well above its melting point, obviously.